So the last time I saw you, I knew how to work a pen. This time, not so much. Last time I saw you, we started talking about graphing exponential functions, right? They were graphing exponential functions is what we talked about last time, right? And they were functions that look like f of x equals 2 to the x power, or b to the x power, right? We had a base. It could have been anything. So I'm going to keep this as b so that we know it could be anything. Right? But it was just something to the x power. For the first time, our variable, right, was in the exponent, right, not in the base. And all we've covered so far are the graphs. And just like the other day, you don't have to know how to make the graphs yourself. I'm not asking you to graph them. I'm asking you to plug the equations into Desmos and then use the graph to answer the questions, right? So you'll have to sketch it, but you don't have to come up with the graph on your own. Desmos can do that for you. But we specifically used a function that was f of x equals 2 to the x power, and we went ahead and we graphed that function, right? I made a table because that's how I work. To me, it's faster than going to Desmos. And I put in values for x. I chose whatever values I wanted, but I always chose some evens. Some positives and some negatives. And here I had like 1/4, 1/2, 1, 2, and 4, right? And these were the values I got. And when I graphed it, it looked something like this, right? Where we had this graph going closer and closer here, but never actually touching it. And then kind of coming up on this side, right, where it was going to go on forever. And we had to answer this series of questions, right? I'm just kind of going over, this is what we did earlier this week, right? And we had to find out what the domain was, what the range was, the end behavior, right? It asked as x approaches infinity, what's happening to f of x, which is the same as what's happening to y. And as x approaches negative infinity, what's happening to f of x or y. And then it asks for the y-intercept. And it asked for the asymptote, right? That line that we can't cross. And these are the things that the graph told you, which is why I'm not making you actually come up with the graph on your own. You can let Desmos do that. But the graph kind of answers all these questions for us if we know what the questions are, right? If what they mean. So when we were looking at range, at domain was anything x could be. And in this case, x could have been anything, right? It could go from negative infinity to infinity. It can go any direction, side to side. It could go on forever. The range, on the other hand, does not go below this line, right? So our range would go from 0 to infinity, or just y is greater than 0. You could write that either way. These are end behaviors. It just asked us to look at the graph. It's saying when x is going this way, when x is getting bigger, what's happening to y? Well, in this case, y is getting bigger towards infinity. So we could just say f of x is approaching infinity. This one is saying when x is getting closer to negative infinity, right, what's happening to y? And it's getting closer and closer to this line, right? So we can say f of x, or y, is approaching 0. Our y-intercept, well, that is where this is crossing right here on the y-axis, right? And if you can't look at your graph and know, like I could look at this and go, okay, well, x is 0 here and I've got 1. And I can look at that and I can go y equals 1 is my y-intercept. If I don't know that, I can take the original equation and I can just plug in, right, to find the y-intercept anywhere. we can just set x equal to 0 and solve for y. I don't know if you remember that from the beginning of the year, but that would give us that f of x or y, right? They're the same, they're interchangeable, equals 2 to the 0 power, right? We had 2 to the x. If we set x equal to 0, right, we get 2 to the 0 power, and anything raised to the 0 power is just 1. So if you can't tell on the graph what it is, just set x equal to 0 and figure it out. The asymptote is just this line we can't cross, and we can see it right here, that it is y equals 0. It won't always be y equals 0. So this is just a quick review of what we did last week. What we're doing this week, ouch, is we're doing transformations on these. And I'm going to give you a few basics of transformations, right? First, a transformation of an exponential function. Those are too far apart. Looks like they're two separate words. But I'm not going to bother fixing it. The different transformations we can have are f of x equals a times b to the x minus h. Notice this is a minus h. That's a very important concept, plus k. And when we look at this, h is the horizontal shift, right? The horizontal shift, right? It shifts from left to right. So if this is x plus 5, it goes this way 5. If this is x minus 5, it goes this way 5. And I know that's contrary to how you feel like it should be, but trust me on this one. Because our formula itself is minus h, for it to be a plus 5, we would have had to put in a negative 5, right? Our k is the vertical shift. It is our up and down shift, right? Right? It moves up or down. So think about that. If something is happening up here, it's happening to h. It's going to change how we graph it from left to right. It's going to add or subtract h number of units from every x value. If I have something over here in k, say it says plus 5, that would move it up 5 units. If it said minus 5, it would move every point down 5 units, right? Every y value. A just tells us whether or not it's a stretch or a compression. So if we have A and it's positive, the absolute value just means it's positive. If it's greater than 1, it is a vertical stretch. I'm not spending a lot of time on this because you aren't going to have to actually do this, right? Because you're going to use Desmos to do it. 0 and A. So if something is between 0 and 1, it is a vertical compression. So these are bits of information to know, but they're not necessarily going to affect you too much in the not knowing. So what does that say? So if I have something like f of x equals 3 to the x plus 5, we're saying that this moves up 5 units. Every point moves up 5 units from the starting point, right? If I have f of x equals -4/3 to the x plus 2 and then plus 7 over here. What we're saying is that, first of all, this negative in front is going to be a reflection, right? It's going to change the sign of everything, so it'll be down. So it'll be a reflection. Should have left it positive. Over the x. It's going to go this way 2 units. Right? And it is going to go up 7 units. Right? So you can look at it and kind of get an idea of what is going to happen. Does that make some sense to you? And like I said, you don't have to know this super well. I just want you to see kind of how they make the shifts, because you aren't going to do the graphs yourself. You're going to plug them into Desmos. But I want you to see how the shifts work. So I like this first problem that I'm giving you. And the reason that I like it is because it's making very little change on the problem that we did before, the one that I went over up here, right? Where we did f of x equals 2 to the x power, right? So we're going to make a slight change on that one. And we're going to do an example where we've got f of x equals 2 to the x plus 5 power, right? And I'm going to do the graph. I'm going to do a table and all that. I'm going to do it here by hand, but then I'll take it over to Desmos and show you how it works there too, so that you get a little view of that. So here I'm going to do my x and my y. And if you remember, when I had the original one where it was f of x equals 2 to the x, I did -2, -1, 0, 1, 2, and I got 1/4, I got 1/2, 1, 2, and 4, right? If I do f of x equals 2 to the x plus 5, what that is going to do is it's going to take every single one of my x values. All my y's will stay the same. 1/4, 1/2, 1, 2, 4. That's not going to change. But every one of these x values, remember I said that the parent function was x minus h. Well, to get this +5, it means we had to put in a -5. So we are going to subtract 5 from every one of these. And we've got -2 minus 5, which is -7. -1 minus 5 is -6. 0 minus 5 is -5. -4, -3, right? And so what it's done is when we graph it, right? All of that stuff that I had in this graph, right? Our original graph, if we look at it, you got that point at 1, right? And it all goes like this. Everything is shifting this way 5 places. So now it kind of goes like this. And eventually it'll cross here, right? But it's the same graph, the same exact graph, just moved 5 places over to the left. That's all that happened with this, right? And so when we go to answer those questions, or we had before, which is what we'll have to do when we had the domain, the range, then we had our end behaviors. As x approaches infinity, f of x does something, right? It approaches something. As x approaches -infinity, f of x does something. And then you had your y-intercept and you had your asymptote, right? Those are the things that we had to find on the other one. These are the things we'll have to find on this one, right? If we look at our graph, Our domain is saying, what can X do? Well, X can go as far as it wants to this way, and it can go as far as it wants to this way. So X can still be all real numbers, right? There's nothing that's changed there. We can still have any X we want. Our range hasn't changed either, right? We're still getting closer and closer to 0 here, but we're never reaching it. We're never going below this line. So we could still write this as 0 to infinity, or y is greater than 0. Absolutely fine, right? If we look at our behaviors, if we're saying as x goes to infinity, so as x is going this way, what's happening to y? Well, it's going up, right? And it's going up forever. Nothing prevents it from going up forever. So we can say y, or f of x, is approaching infinity. As x goes this way, as it gets further and further towards negative infinity, we're no longer going to negative infinity, right? Because we can't cross this line. So x is getting close, y is getting closer and closer to 0. See, none of this has changed for us, right? What has changed is our y-intercept is no longer 1, right? And we don't know what it is, but we can go, well, we've got f of x, or y, equals 2 to the x plus 5. And we know for y-intercept that if we set x equal to 0 and solve, we'll know what our y is, right? So we can call this y equals 2 to the 0 plus 5, which is same as saying 2 to the 5th power, which is 32. So we could just say y equals 32. Has our asymptote changed at all? Has the line that we can't cross changed? No, it's still going to be y equals 0. So if we, like, I did this graph for you, but what if I didn't? If I didn't, here is our original, right? Our y equals 2 to the x on Desmos. I just plug that in, right? Our new one that we just worked on, I could write in as y, I don't need a space there, equals 2 to the, I'll put it in up here in parentheses, x plus 5. And so here's our new one, right? It's the same graph moved over 5 places. We still can't see our y-intercept in it, right? Because we'd have to go all the way up to 32 to see where it crosses, right? But you don't need to do that because you know how to find a y-intercept, right? You can just plug in 0 for x and figure it out. So this is your benefit. You don't have to come up with this graph on your own. Sketch me this graph on your paper and use it to answer all of your questions, right? It tells you everything you need to know. I am going to do one more quick example because I want you to see a different transformation. I want you to see what happens when it moves up and down because that's going to change things a little bit for us. Let's get rid of this one and put in a different one. And I'll show it to you on this graph first. I want one that looks similar. I just want to make a change on that same. I want to do, I got it. Let's do y equals 2 to the x plus 5 this way. Let's go minus 5. Let's go minus 5. So if I go 2 to the x, this is our original function that we've been dealing with, right? It's the one we did in the example the other day. I redid it earlier. We just added 5 to the x earlier. Now we're subtracting 5. And notice what it does is it drops everything down 5 points. But this is going to drastically change some of those problems that we had. And so I'm going to come over to the whiteboard and I'm going to show you how to write this one up, right? So if I have f of x equals 2 to the x, what did we say? Minus 5, right? If we look at our original f of x table that I made, right, where we had our x and our y, and we had negative 2 was 1/4, we had negative 1 was 1/2, 0 was 1, 1 was 2, and then we had, this was f of x equals 2 to the x, not 2x, 2 to the x, right? And 2 equals 4. What's going to happen when we make the chart for this one is all of our y values are going to go down 5, right? We can just subtract 5 from each one of them. So here, if I have my x and y for this transformation, our x's would stay the same, but our y's would each be minus 5. So this would be 4 3/4. This would be 4 1/2 minus. Right. This one would be 0 minus 5, which is minus 5. This would be 1 minus 5, which is minus 4. 2 minus 5, which is minus 3. Oh, man, no. Why did I do that? I lost it over here. This one is right. This one is, I started subtracting my x's. Sorry, I'm really tired today. 1 minus 5 is minus 4. 2 minus 5 is minus 3. 4 minus 5 is minus 1. And you guys have already seen the graph, right? We already showed it to you on Desmos, right? It just dropped everything 5 places, right? So now I had my point down here. Here at minus 5, we have our new asymptote, right? How do I know it's at minus 5? Any idea how we know it's at minus 5? Kind of because of the f of x, because we know that the original one, right, before we made any changes, was at 0, and we've dropped everything 5. So the asymptote also gets 5, dropped 5. Does that make sense? So we know it's at minus 5. So now our points are getting closer and closer to negative 5. And then they're going to come up on this side, right? So when we look now at our domain and range, or at all our questions, so we've got domain, range. So much easier when I have the worksheet. I don't have to write all these out. Then we could do as f of as x gets closer to infinity. Man, I'm so tired today. As x approaches infinity, f of x does what? As x approaches negative infinity, f of x does what? Y-intercept and asymptote, right? Those are the things that we need to figure out. And our graph shows them to us, right? Our domain hasn't changed. Our x's, we could still go as far as we want that way with x's and as far as we want that way with x's. Our arrows tell us that. They're going in opposite directions forever and ever. So we could go, domain is still negative infinity to infinity. Our range has changed though, right? Before we were starting at 0, now we're starting at -5 is the lowest, right? It's not going to touch it, but it can go as close as we can get it to -5 forever and ever. But it's going to go to infinity, just like before, right? It's still going up forever. Our y's in that upward direction can go on forever. Nothing will stop it. But here we're stopped by this line. And that kind of tells us with our, as x approaches infinity, what's happening to y as we go this direction with x, our y just continues to go up forever. And so we're saying that that is going to approach infinity. As x approaches negative infinity, as it's going this way, it's just getting closer and closer and closer to -5 forever. So f of x approaches -5. Our y-intercept, technically we know what it is because it just moved down 5 points from the last time, right? But if we don't know what it is, we can still plug it into this equation that we have. So we have f of x equals 2 to the x minus 5, right? That's the same as saying y equals 2 to the x minus 5. And all I would have to do is plug 0 in for x and solve, right? And when I do that, I get y equals 2 to the 0 minus 5. Anything to the 0 power is 1. So it's 1 minus 5, which is -4. Now, we could have looked at it and just figured that out, right? Well, when I showed it with these points. But we knew that the last one was at 1, so we would just subtract 5 from it. But we can go y equals -4. Our asymptote, we already determined, was here down at -5 when we talked about our range, right? So we know we're not going to get past y equals -5. So everything solves out the same way, except for now we've got these transformations. Otherwise, everyone would have the same exact answer, right? But as they change, as we do certain things to them, they're gonna shift. So I just wanted you to see those shifts. Plug the equations into Desmos first. I put the link for Desmos in PowerSchool. I put the worksheet that you need to do into PowerSchool. But really what you're just doing, the whole point is for you to look at the graph and tell me what it's doing, right? It's to show the tendencies. It's for you to understand what these changes look like and what that looks like algebraically right here. Any questions regarding any of that? I feel like I've been talking an awful lot right now. I'll stop the video because it's getting